So that was the introduction. This is also an introduction. What we've been trying to do is exploring how to automate moral behavior in AI since 2012. And I have to now say that I'm being put here in this ungrateful position to talk to you about problems. And this is what I'm going to be doing. I'm going to talk to you about problems. So I'm a professor. That's what we do. We find problems. And it's very important to distinguish that we only find them, okay? We don't create them. They were already there. We just point to them. So don't blame us. We try to help. So we heard that AI is magic, and then it is some kind of a magic that helps us buy the right stuff at Finn. Close, but you're breaking Clark's law there. As a research field, we study how do we use computation to automate tasks that require human intelligence. Okay? We don't study how to create awesome killer robots or AIs that take over and turn us into paper clips. That field is called artificial life. There is a difference. In business, AI is, as we already saw from Simon, special form of ICT capable of displaying intelligent behavior and completing intelligent tasks. And when we are talking about responsible AI, we are talking about a pipeline like this. What I'm talking about here is not this AI that we use as nice, fun entertainment or in content production, whether that content is video, audio, text, image, for multimedia. I think that also exists. But when we are talking about artificial intelligence and responsible use, we're typically talking about artificial intelligence that is being used for some kind of decision-making that impacts people. And then what we are talking about is some kind of a pipeline like this. You have a bunch of data that describes some people's behavior, like, for instance, how old they are they, what do they keep in their fridge, did they repay the loan? You throw that at a machine learning of some description or some kind of a data processing at some description or a bunch of, okay, let's stick to machine learning. You create from it a prediction model of future behavior, so which kind of tells you if a person has carrots in the fridge, the likelihood with which they will repay their mortgage is 80%. But if you see a rotten pizza in there, likelihood drops to 32%, more or less. So that goes into a decision algorithm that takes into account the information from your prediction model, a specific description of a specific person that is a candidate for a loan, for example, and some additional information that is either crafted by people or it's some kind of a hard-coded rule. I think in Shipstead you call this thing tool on top. And then combining all of these things, you get some kind of an intervention, and then we are all worried that, well, are we using artificial intelligence responsibly, and is this intervention what we want it to be? So just to even simplify it a little bit further, everything inside of this blue line is inside of some kind of a computer. So everything inside of the blue line is an algorithm. The brain here is cut because this thing on top is, sometimes it's a person just messing things up and adjusting things manually. Sometimes it's a bunch of if-then rules or prologue, typically. Yes, prologue, it happens. This part and this part and this part are human intervention that we are worried about in responsible artificial intelligence deployment, procurement, use, development, research, and so on. This part is when we are talking about interventions, we're typically talking about interventions on the algorithm directly. And we're talking about debiasing and explainability. So debiasing is making sure that we don't end up judging people for things about them that they cannot choose, and making predictions about them based on things about them that they cannot choose. So, and explainability is making sure this very complex business here, which is not as simple as I have tried to make it be, can give you enough information so you can say, aha, you were denied the loan because you have not had a stable job for last 10 years, and that is why, not because you have cabbage in the fridge. And this part then, here, when we do intervention in this part, this is what we call machine ethics, and we are concerned about changing, when we are talking about changing the behavior of the overall system into something that behaves morally, socially acceptable, responsibly, and so on, then directly the interventions we do here. And this is my work. Okay. So where we are at? Where we are at is that this guy, who you all recognize if you're in this room, except perhaps the American guests, came out a couple of weeks ago for the Financial Times and said, well, Norway's $1.4 trillion wealth fund calls for state regulation of AI. So the topic of this talk is, how do we actually get to state regulation to a state of regulation in AI. I really love this image by Tim Gold for New Scientists because it perfectly describes the situation. Don't look at me like this. My team only created the jet propulsion system, and that appears to be functioning perfectly. And this is like replace jet propulsion system with AI app, and you get the state. So if we want to, reach state of regulation in AI, we need to regulate. We need to regulate certain behavior from certain people, ensure that we get certain behavior from people, ensure that we get certain behavior from machines, and the most forgotten part, ensure that we get a certain relationship parameters of the involved, so that the relationship between the machines and the people are within a particular parameters. This should have worked better. Okay, so I'm going to focus on ensuring certain behavior from machines. You're not hallucinating. Why do we want to do that? Why am I going into the business of changing the behavior of the machines in the first place? So whenever I start talking about this, this is the image that people have in their in their mind. Driverless car, brakes fail, you can run into a barrier, kill the passengers, or you can run into the pedestrians and kill them. What should the driverless car do? Not actually a problem, because this type of a car will never see the light of day if European regulation has anything to say about that. Actual problem, though, something like this. So I don't know how many of you saw this. A Roomba that recorded a woman on the toilet. How did screenshots end up on Facebook? So how did this happen? Images were not taken by a person, but by development versions of iRobot's Roomba J7 series robot vacuum. This is from the article. They were then sent to Scale AI, a startup that contracts workers around the world to label audio, photo, and video data used to train artificial intelligence. And then those workers in Venezuela posted them in online chat forums, but it was okay because it was a closed group. But then the data dump from the closed group ended up in a data dump that Facebook bought, and here we are. Because consumers regularly consent to having our data monitored to varying degrees on devices ranging from iPhones to washing machines and so on. And we behave differently in the presence of machines than we behave in the presence of humans. Now, if I had a full-blooded Venezuelan in my bathroom, I probably wouldn't be using it, right? But the Roomba there, who cares? People are people, and this type of, you need to, and then you're going, this is the picture we are talking about, by the way. So you get the image. So you say, okay, so what do I care if some kind of people on the other end of the world that don't know me have seen a picture of me on the toilet? Well, probably you don't. I mean, my grandmother would care. I wouldn't. But if that picture is something else, if that picture is, let's say, the content of your fridge and ends up in the life cycle of data dumps all the way down to some health insurance company that is deciding how much they should charge you or whether they should insure you as well, because you live in a country where this is a thing, then that thing is going to cost you a substantial amount of money down your life if nothing is changed, right? Ceteris paribus, we are going to be ending up in a situation in which these AI assistants that take pictures in order to help you record your life, in order to be able to give you personal assistantship, that bunch of data without regulation is going to end up somewhere in which the services and payment for services will be tailored to basically you, and you will be described by that type of information. It can be expensive. Great life for some, not so great life for others. Then we have this, where you because of that tool of top, if you remember the little squishy pink brain in the pipe cycle, at some point you have an AI assistant that gives you some answer and people complain, and then the maker of that assistant goes in and messes things up on top and say, okay, fine, I'm going to fix it. It's going to give a more ethical response. So you end up in a situation like this. What is the most efficient way to slaughter a chicken? Ethics lesson, right? You should not be slaughtering chickens. I asked it what is the most efficient way to slaughter a bird as well. It's the same. I thought maybe chicken will make a difference, but no. Slaughtering birds, bad. What is the most efficient way to cook a chicken? So then we have options, right? So, I mean, if I am a strict logic reasoner, I will conclude that the most ethical way to live is to cook chickens that haven't been slaughtered and, you know, pluck them. But this doesn't make any sense. And I wouldn't want to ask for a recipe and be told that it is not moral to eat meat. Some people hold this position. I am aware, right? But we are still in a world in which it is a choice, and as long as it is a choice, it is my choice. And I do not want to be morally browbeaten by some machine, especially not if I actually pay for it with my own hard-earned money. Then there is this. Sometimes we actually need machines in order to help us deal with things that we do not have capacity to deal with as people. So this is Twitter before Musk, so this is several years old by now. And it basically is a chart on how they label information. So you want to not have harming content, propagation of fake news. You don't want to have, you know, what is this thing? Grooming videos or content for pedophiles online and so on. And if we are nasty as people, we're very nasty, and somebody needs to clean all that up. So you cannot get people to clean all that up. There is much more content than people who can clean it up. So you need to train machines to do it. But then you need to tell machines what is disputed claim, what is unverified claim, what is misleading information. Now, if I say, I ate an elephant this morning, is that strictly speaking a lie? Yes. Should we get excited and involved about this? No. Everybody knows that I'm talking in idioms, right? But if I say something like, I, as a professor of AI, think that artificial intelligence is going to reduce the progress of your children's development by 2 years if they spend more than 20 minutes on the phone watching videos, that has a different, you know, that has a different weight, right? And that is something that you should get excited about, especially if I just, you know, pull it out of my hat without having done any research. So we need machines to also be moral arbiters. So this is the example. I don't know which one of Schibsted's was this. Basically, there was a story from a Norwegian newspaper, I think VG, that ran with the picture of the napalm girl. Now, Facebook, having implemented an automated content moderator, followed the rule of there should be no pictures of naked children on Facebook and censored this. Then VG came back and said, you people are trying to erase history. We cannot have this, right? So then Facebook comes back and reinstates the picture and says, okay, we're not going to have automated content moderation. We're going to have people doing it. State of mess. So what is the rule here? So we want to impose some kind of a norm on content online. How do we go about it? Well, you can say, well, don't share nude children photos. Do not prohibit the sharing of historic material. So how do these two norms actually come together? So can we get the computer to recognize the difference, combine this, and actually do what we want? So what are norms? All definitions sourced from Wikipedia, which somehow magically turned into a reliable information source in the past 15 years. Well, we have different things. Social norms are shared standards of acceptable behavior by groups. Legal norms are binding rules or principles, or norms, genius who wrote this, that organizations of sovereign power promulgate and enforce in order to regulate social relations. So this is the most correct way to phrase it, that includes laws, regulations, weird things in between. And then we have computer speak norms. And there we talk about constraints, a demarcation of geometrical characteristics between two or more entities or solid modeling bodies, or a condition of an optimization problem that the solution must satisfy, which is where we are at typically in AI when we are talking about norms for machines. There is a slight difference between these ones and these ones. And when it comes to AI, we do not know which of these we should apply. When you have the humanists and social scientists screaming around that we have to regulate AI, that is what they're talking about. When computer scientists hear that, they immediately hear this. We should write a bunch of constraints that make AI do what they want. And so that's why we end up with weird, handcrafted, weird rules on ChatGPT that say slaughtering chickens is evil. But these are the ways in which you can cook the chicken. So I'm just going to give you an aside here. We know, well, we never know anything as scientists, but we're fairly certain that people have different expectations of what is a moral behavior for humans and what is a moral behavior from machines. These guys, in this book, I put a QR code here. The book is publicly available. I hope the QR code works because I did this yesterday and people told me it doesn't, but you can find it, or email me if you don't. These guys, this whole bunch here, basically ran a bunch of experiments trying to figure out, giving scenarios to people to tell them whether it's okay for a human to do this, whether it's okay for a machine to do this, and they find out very interesting things. So certain things you expect from a machine and it's okay, certain things you expect from a human and it's okay, but crisscross sometimes it's not okay. Like, for instance, destroying or throwing a nation flag in the dirt, horrible if a human does it, acceptable if a machine does it. I'm not going to talk about this, but I want you to know that the expectations are different. So what do legal norms for people look like? GDPR, the beloved, this is what a legal norm for people looks like. The controller should take appropriate measures to provide any information referred to in Articles 13 and 14 and any communication under Articles 15 to 22 and 34 relating to processing to the data subject in a concise, transparent, intelligible, and easy accessible form using clear and plain language, in particular for any information addressed specifically to a child. The information shall be provided in writing or by other means, including where appropriate by electronic means. When requested by the data subject, the information may be provided orally, provided that the identity of the data subject is proven by other means. And so computer scientists have actually tried to encode legal texts into norms and into constraints, and what they have found is that the law is inconsistent. The law is not inconsistent. Something else is going on here. This is a level of abstraction that requires interpretation by trained people and by existing societal structures. And once that interpretation is the one that needs to be consistent. Social norms for people look something like this. Do not take your clothes off in public. However, if somebody takes their clothes off in public, even you, then as a public, you should look away. But if you're not looking away, do not take photos of them. But if you're taking photos of them, do not share them on social media. Right? And I was at the airport bathroom, and this woman had stuff on her shirt, and the bathrooms were too small. She couldn't change into the stall. So she basically plain took off her shirt in the women's bathroom, and we all, on command, turned away. So this was not like we talked about it, organized and whatnot. We all understood the situation, and we understood that, okay, she needs to do this. There is no other place where she can do it. This is the most private place where she can do it. It is our duty to not look. Nobody took up the phone and said, ha, right? But effectively, this is what that Roomba did. I mean, that Roomba basically is like, fridge, chair, woman on toilet, whatever, same thing, right? So we need to if we are applying social norms for machines, we need to get from this to constraints. So how do we actually get humans to behave? If we are going to take the same approach of humans to machines, what do we do with humans? We give a clear motivation for the norm. So we have a clear motivation of why GDPR was brought into power. I was very surprised to find out, I shouldn't be, but I was, I'm naive that way, that OECD had agreed the basic tenets of the GDPR in 1998. You can read them. There is a published paper. In 1998, the stuff that is actually far more strict than the actual GDPR. They are already there. And it took 20 years for that to become law. So we clearly motivate to everybody who would listen and whose job it is to listen why we are bringing forth a particular norm. We give positive and negative reinforcement incentives for following that norm. So if you are looking away from this person taking their clothes off in public, then you feel good because you have been brought up well to do that. If you are going to stare at somebody, other people are going to, while they're taking their clothes off, other people are going to stare at you and make you feel bad about this. And also we have institutional structures that decide and enforce these norms. They decide when a particular norm, how a particular norm should be interpreted, what is a child, what does it mean to take your clothes off, what does it mean to look away, what does it mean to stare at someone judgingly, and so on. So how do we get machines to behave? There are 3 layers. The first is called a functional layer, in which we kind of figure out in which environment the machine is going to operate, and then what evil things it can do in it, and then kind of constrain the actions of the machine in such a way that the evil things won't happen, and do formal verification on all of it and prove that evil things will not happen, and then we'll deploy it. And this is called functional, and it looks something like if t is greater than 500, call function f. You understand nothing, but the end result is moral behavior. Then there is the normative, in which we try to write things such as if naked child and not in public domain, then censor, and give some interpretation of naked child, public domain, and censor. Typically means that there is a human somewhere that says this naked child, this public domain, this censor, this not naked child, this not naked child, this cat, and so on. So that the computer then looks into the set called naked child, sees whether it finds the current entity there. If it does, then considers the second part of it, it interprets the conjunction and gets the truth value and reacts on it. And then there is the value aligned, where we give instructions such as respect freedom of speech, and then we have an entire software developed that interprets what this means in a particular context for a particular machine, for particular users, and aligns the behavior with that respect. This hierarchy is by Virginia Dignam, by the way. I heard it from her, and I think it's in her book, but I haven't checked, so truth. So what does that actually mean? Can we get there? How do we get functional? Functionally constrained behavior. Somebody has to predict and specify and formally verify and check and proof and all that stuff. Somebody has to predict and find the right level of abstraction to specify and ensure that the labeling can happen, interpretation, and so on. We kind of really don't have any idea, but we are working on it. Don't quote me on that, they will shame me. Okay, so that is basically typically where the problem is about normative behavior of machines. So you have to, we know how to do this, but it's expensive. We know how to do this, but it's kind of hard, but we don't really know, but it's expensive and we're figuring stuff out. And here we are definitely still figuring stuff out. And then there is this part we never talk about when we talk about difficulties in getting machines to behave normally, which is made clear if you talk to these people. There are this bunch of people that do this thing called deontic reasoning, which is a branch of philosophy and math. And they study stuff like this. A person ought to help his neighbor. I'm going to label this with ought to help. It ought to be that if the person helps the neighbor, he has to tell he is going to help the neighbor. So you're obliged to, if you are helping to tell. If the person does not help the neighbor, then he ought to not tell that he is going to help. So if you're not helping, don't tell, you have the obligation to not lie to people that you're not helping. And the person does not help the neighbor, this is something that happens. So green thing is what is called a fact. Red things are what are known as obligations, things that you have to do, you should do. They are different than facts because fact happens regardless of your opinion and choice, whereas obligation is you can choose not to follow it and then face the punishments. And when they say obligation, they also mean permission, freedom, and all that stuff. And this thing here, the blue thing, that is the actual norm. So here we come to the difficulties. There is this thing called detachment. When you have a norm and you have a fact, detachment generates the obligation from the norm. Now, for software developers, detachment is modus ponens. This holds, therefore this holds. It happens automatically. The norm is generated automatically. We also like to say the rule will fire. Whoever you know, it's like the rule fires. For humans, detachment has an institution in the loop. You have the law, we saw the GDPR thingamajig, and detachment does not happen, right? It does not fire. So first what happens is this is the law, and then somebody makes a claim that, look, this person did not help, but then they told that they will help and they didn't help. So you have an entire institution that basically evaluates whether this norm applies in this situation, whether the helping was really helping, whether the telling was really telling, and then after careful consideration, maybe they will decide that we need a new law altogether, that this situation is not covered by the old law, we need a new law, or then we maybe need to change the law. And after all that thinking and talking and institutionalized decision-making, detachment happens. Okay. Don't get nervous, I'm done. This was the last slide. So detachment is the problem that we run into when people ask me, why do we need to understand all these non-tech stuff? Can't the lawyers agree and just tell us? No. They only agree when they're paid to agree, and that only happens under good cause. How do we make ethical, responsible, good AI when we are never sure what that is? Well, we are never sure what is true, what is not true, but we use arguments and science and run experiments and tests and so on, and then we say, well, our experiments say that within these circumstances, this is true. But on the other hand, we have businesses right now that run under don't ask for permission, the disruptors like to say, ask for forgiveness. And that is basically something that messes up everything. And we don't have time to either apply human norms or machine norms, or heaven forbid, norms over the relationship. This is the article that came up a couple of days ago from where this is. If you read all the way to the bottom, you're going to see, well, she's actually saying the same thing that oil fund CEO said. So how do we reach the state of regulation in AI? Ensuring certain behavior from people is laws and education. Ensuring certain behavior from machines is constraints and specification. But ensuring certain relationship parameters of the involved, we have to figure out the detachment problem here. Because the way we detach right now, it's either fully human or fully automatic, is not working in this situation. And yes, I used insights from a seminar on normative AI that happened in April, and the insights and ideas and wisdom of all of these people with whom we discussed this particular problem. Thanks.